Hi everyone, welcome to moscan. So in today's video, we have been given two common source amplifier configuration. The figure first, which you see on the left side, is a normal common source configuration amplifier, whereas the figure 2, which is on the right hand side, is also a common source configuration amplifier but with source degeneration. And in this question, it has asked to plot the GM versus V in curve for both the amplifiers. So we will start from the figure 1 itself. So if you see, the figure 1 is a normal common source amplifier, and we know GM equation for any MOSFET which is operating in saturation can be defined by GM equal to mu n Cox W by L into VGS minus VT. Right? GM equation can be written in other formats also, like this is one format. The other format GM equation in saturation is twice of ID divided by overdrive voltage, which is equivalent to VGS minus VTH. There is one more equation of GM for saturation if the MOSFET is operating in saturation, that is defined by twice of mu n Cox W by L into ID. So depending on the situation, we can pick one equation and then we can see how the GM curve will look like. So if you see here, source voltage is constant, that means 0, whereas gate voltage is Vin, which is varying, right? So if Vin is increasing, that means your VGS will increase, right? Because VGS for this MOS is nothing, Vin minus 0, that is equal to Vin. So if Vin is increasing, that means VGS will increase. And we can use this equation, right? Because VGS is varying, that means your ID will also vary. So ID is not static here. If ID would have been static, we could have used some other configuration of GM equation, but we will use this one. Here ID term is not there, only VGS minus VTH is there. So if Vin is increasing, this means this term will increase. That means GM will linearly increase if we are increasing the Vin voltage. There is one interesting thing here. While drawing the plot, you will get to know. So let's start drawing the plot here. We will draw GM on the y-axis and we will plot Vx on the x-axis. Now, it is certain that once V would be greater than Vt, then only MOS will have some transconductance value that it will operate in saturation. So let's say this is Vt. So once your Vin is greater than Vt, then only your GM curve will start rising. And if you see here from this equation, there is a linear relation between VGS and GM. That means if V is increasing, GM will also increase linearly. So this is how your GM curve will look like. It will go linearly. It will rise linearly. But there is one more fact. There is no upper limit given to Vin voltage. That means Vin will start rising from 0 volt. It will rise till V0 value. And then it will rise beyond V0 also. Let's say it rises till V0 plus Vt. Then what will happen? Let's try to understand. We know in order to operate this MOSFET in saturation, VDS should be greater than or equal to VOV, that is VGS minus VT. Now, since source voltage is 0, so we can directly write it as VD should be greater than or equal to VG minus VT. Now let's say if VG voltage is equal to V0, that means in that case, still your MOSFET will operate in saturation because this term will be definitely lesser than V0 by VT term, right? VT is getting minus here. But once your VG will become equal to V0 plus VT, then if you see here, VT will get cancelled out and your VDS will be equal to your VGS here, right? That means if we make this VG slightly more than V out plus VT, your MOS will start going into linear, right? Because this term will no more be higher than this term. This will become greater instead of this VDS. So that means your MOSFET will start going into linear region, and in linear region, GM equation can be given by mu n Cox W by L into VDS. Since VDS will decrease if you are increasing the gate potential, ID current will increase. That means this potential will drop down your VDS will decrease. That means your GM will start decreasing after that. So till this point is nothing but V out plus Vt. Till this point GM will increase, and after that GM will start decreasing. So this is how the curve will look between GM and V for the figure 1, which is normal common source amplifier. Now we will draw the same figure for figure 2, which is common source amplifier with source degeneration. Now let's talk about the second case. So if we have to calculate the VGS here for second figure, like common source with source degeneration, so for this figure, VGS can be written as VG minus VS, right? VG is V in, and VS, we are calling this net as VS. And this would be equal to ID into RS. We are assuming ID current is flowing in this structure. So I can write it as ID into RS. RS is source resistance, source degeneration resistance. Now we know this ID is drain current of this MOSFET that can be given by GM of this MOSFET into VGS of this MOSFET, right? And RS is anyways there. So this we are calculating VGS. So if I bring this term on the left hand side, so I can take VGS as a common, I will get 1 plus GM into RS, and that would be equal to V in, right? Now one thing we need to understand here is transconductance formula for any MOSFET structure can be given by I naught upon V in, correct? It's the opposite of transconductance is the opposite of resistance value which we get. So usually we get V by I equal to resistance, but if we take the inverse operation, that we will get transconductance. Now I naught in this circuit is nothing but ID, same current will flow, right? Because both are in series. And V in we have anyways calculated here. So if I put this value of V in here, what I will get here? VGS into 1 plus GM into RS. Now ID, we know we have substitute ID with GM into VGS here, so I can replace this with GM into VGS. VGS will get cancelled out, and ultimately I will get GM upon 1 plus GM into RS. If I take GM as a common, so I will get 1 upon GM plus RS. Right. Now if you see here, if I have to plot GM curve with respect to V in, so as we have saw in this figure 1, once your MOSFET will start operating in saturation, that means once your V in is greater than threshold voltage, at that time GM was increasing linearly. So here also it will increase linearly. But the second condition will be opposite here. As soon as your V in will continue to increase, your GM will continue to increase, and this parameter will become negligible. So your transconductance value would come only equal to 1 upon RS. So that means after certain point, your GM will become constant as it will saturate, and its value would be equal to 1 upon RS. So this is how your GM curve will look like for the equation figure 2, where common source is used with source degeneration resistance. GM will increase initially, but after a certain value, it will be saturated, and the maximum GM value will be 1 upon RS. So this question was about plotting GM versus V in curve, and we have plotted for common source amplifier and common source with source degeneration amplifier. I hope you found this video useful. If you learned something new from this video, please share this video with your friends, and if you haven't subscribed to our channel, please do subscribe.